This video is all about alkynes. So if you haven't seen the video of the alkanes and alkenes, please check that one out first. An alkyne has a triple bond in the hydrocarbon. And again, just like the alkenes, there is no methine. Methine does not exist because we cannot triple bond a carbon to a hydrogen. Okay, hydrogens are only single bonds, and even though carbons can make four bonds, they can't triple bond to a hydrogen. So we're going to also contain with the eth, prop, bu, pent, hex, hept, octanone, and decyne in here. So an ethyne would be C2H2, and we would have a carbon triple bonded to another carbon, and then since each carbon can make four bonds, we would add in a hydrogen on each one. Propyne would be a triple bonded carbon to another carbon, and then a single bonded carbon. How would the hydrogens look? There would be one hydrogen on this terminal or end carbon here. How many on the central one? None, because it already has four bonds, and then you would have three over here for a total of four, C3H4. Butene would be one, two carbons in a triple bond, then you would have two after it for a total of these three after the double bond. Then you would have one hydrogen, no hydrogens, then you would have two, and then you would have three for C4H6. Pentyne would be C, triple bonded to C, carbon, carbon, carbon. One hydrogen, no hydrogen. 1, 2, 3, 4, 5, 6, 7, and then our eighth one. So our general formula for an alkyne is CnH2n minus 2. So to finish this out, we have hexyne C6H10, heptyne C7H, that's right, 12, octyne C8H14, nonine CnH16, and C10H18 for decyne. All right, so just like we saw in the previous video, there are multiple ways for showing our alkynes, but the major important part is that we are looking at that triple bond. Okay, so an alkane, an alkene, and an alkyne in alphabetical order is single, double, and triple bonded carbons. All right, CnH2n minus 2. Again, the lowest numbered carbon gets the bond. So if we are looking at our normal pentyne, you would have your 5 carbons, and you number your carbons. You would call this your 1 or normal pentyne. And if you had your carbon triple bond in here, where you have carbon 1, 2, 3, 4, 5 indicated, you would have your triple bond between the 2 and the 3, and this would be named 2-pentyne. Okay, if you numbered it from the other direction, 1, 2, 3, 4, 5, going from 3 to 4 is not going to be lower than from 2 to 3. So always number your substances both in the forward and reverse orders, just to make sure that you are going to get the lowest carbon getting the special name of the bond. Okay, and an organic chemist would draw these either this way with a triple bond. This is going to be your normal pentyne, or your 2-pentyne would look like this. And you would put your double bond between carbon 2 and carbon 3. So to number these, this is carbon 1, 2, 3, 4, 5, and you'll see that it's between 2 and 3. Okay, so that is your alkynes. All right, so to summarize for you, you have alkanes, alkenes, alkynes. They are single bonds, double bonds, or triple bonds with these specific formulas for each one, because carbon can make, that's right, 4 bonds. We can also then get into a variety of other things when we start talking about benzene rings, and we have alternating double and single bonds. So sometimes they are shown as this, or this little 0 inside to show that all are equal. But there's lots and lots to learn, but hopefully this is a nice little introduction for you. So stay tuned for the last video, which is all about substituted hydrocarbons and how we can do those fun examples together.